Quality roadways and airfields are built from the ground up. Trimmers are an important machine to create a smooth, accurate grade for paving operations. They shape the aggregate base to the required line and grade on long, linear projects such as roads and airfields, curb and gutter, and linear foundations. Trimmers are highly specialized machines that establish the vertical and horizontal profile. Automatic trimmers enable grade control to tight tolerances, producing accurate base profiles. Grade finishing operations follow closely behind excavation or compaction operations. Here the trimmer is fine grading crushed aggregate base a day prior to concrete paving. Trimmers can also be used to place concrete for slip form paving operations. Larger 4-track, multi-lane trimmers and smaller 2-track machines are available depending on project size. Small trimmers are commonly used for bridge approach, parking lot applications, and narrower 2-lane roadways. Wide tracks reduce ground pressure and provide a good traction on crushed aggregate. Each crawler has a vertical strut that is hydraulically adjusted either manually or by the automatic control system. The actual cutting of the grade is accomplished by a series of cutting teeth mounted on a full-width cutter mandrel. The cutter assembly is usually fixed at the ends, but it can be segmented, allowing for the shaping of the crown. Here, a single segment mandrel can shape the base across one lane to an accurate 2% cross slope. The tips of steel cutting teeth can be replaced as needed. Side plates confine the trimming width and can be hydraulically adjusted. An adjustable moldboard assembly follows the cutter mandrel and strikes off excess material. An auger directing the spoil follows the moldboard and directs the excess material to a wastegate. At the wastegate, excess material is routed onto a conveyor belt for discharge. The conveyor belt consists of a rubber belt and pulleys. The bottom portion of the circulating belt is pulled towards the machine with a motorized pulley. Pulleys that are not motorized and carry the weight of the belt and material are called idlers. Trough idlers supporting the top portion of the belt form a concave shape to allow material to sit on the belt during transit and prevent spilling. Return idlers on the bottom half of the belt are straight and safely guide the belt back to the motorized pulley. The belt is made of flexible rubber that is reinforced with cords made of steel or synthetic fibers for tensile strength and durability. Belts, motorized pulleys, and idlers are routinely inspected. Bearings on some idlers require periodic greasing, while other models have a sealed system that is maintenance-free. The operator can adjust the belt speed proportionally with the material quantity and machine speed. A gathering and discharge conveyor system is standard on many trimmers. These attach to the rear for moving and reclaiming material from the finished grade. The material can be directly loaded into trucks or deposited on the shoulder. The spoil can be cast to either side of the machine in windrows. Here, material is cast towards the joining lane to provide necessary material for future trimming. Both the large and small trimmers use the same general mechanical control systems. Traditional string lines and more advanced GPS technology guide trimmer elevation. Automatic trimmers use a sensor control system that establishes the elevation and cross slope of the mandrel and cutting teeth. It uses input from either an arm riding on a grade wire or a ski riding on an established grade. A tightly stretched wire establishes a reference for the trimmer at a known elevation above the specified project grade and at a known offset distance from the alignment. A horizontal movable arm that is spring tensioned and attached to the trimmer rides on the wire. This arm is connected to an electric switch and activates control signals for the vertical movement of the trimmer. On projects where existing grade needs to be matched, a ski-type runner travels over the existing surface and controls the vertical elevation of the trimmer. Here, the adjacent line has not been graded, so the control system relies on the string line. Production of a trimmer is usually measured in square yards or square meters per hour. Full-width trimmers have operating speeds of about 20 to 30 feet per minute, but speed depends on the amount of material being cut. The operator coordinates deliveries of crushed stone to low areas to provide the correct elevation. Here, deposits of aggregate to correct low areas in the trimmer's path slow the forward speed. In the case of the smaller single-lane trimmers, operating speed can increase significantly. Some of these machines are rated at over 100 feet per minute, but again, speed is controlled by the amount of material being cut. Here the trimmer is reversing direction to begin preparing the adjoining lane. Tracks allow a tight turning radius. As operating speed decreases, quality usually increases, and the speed at which a trimmer can accomplish quality work depends largely on the type and quantity of material being handled. Quality pavements and airfields are built from smooth base profiles. Modern technology enables accurate grade control, and the trimmers play an important role in creating a smooth base built to tight tolerances.